I came up with this activity once when I was feeling sick at home, and I had peppermint tea, and when you boil water to make the tea, it takes forever to cool down, and every time you take a sip you're going to burn off half your lips, and I was wondering how long it takes to actually cool down some peppermint tea. So what I did is I took this to then when I was fully recovered, and we had to cover this topic in further maths, what we did was we actually got some tea, got some tea bags, and actually made cups of tea. And then what we did is we cooled to see how long it would take to cool down over a period of time. So I thought it would be kind of tedious to have to show you a cup of tea cooling down on video. So what I've done is I took some averages. We waited over time. We did 15 minutes to see what the temperature was, and we did an average, and we got these results. I would suggest you'd pause the video right now so that you can enter these results into your CAS and you can do your transformations. Good. So what I'm going to do now is show you what this particular graph looks like. So if I go to set graph setting, list 1, list 2, let's go and have a look at this, friend. And in fact, we may as well do our linear regression here. Regression, linear reg, list 1, list 2. And we can see here we've got an R value. It's not a bad R value. It's negative 0.97. 978. We've got here. There's our line, and as you can see, we've got a non-linear curve forming. And in fact, if I was to do that same thing again, regression, linear reg, and then copy the residuals into list 3, and then show the residuals, which remember is our measure to see if something is linear or not, should come up with a very pretty pattern. So if we go to list 3, bang here, there it is. So you can see that there's our lovely curve in the residual plot, which means there's a pattern, which means that it's not linear, and we cannot accurately predict things in a linear fashion. So we have to see which of our parts of this circle of transformations does this look like. This looks like this curve here, which means we have 4 possible strategies that we can use. We can either do the reciprocal of the x, the reciprocal of the y, a logarithm of the x, and a logarithm of the y. Because remember, the whole point is that we're stretching and changing these scales in order to get this curve to look more like a straight line. So we're going to start with log y. So I'm going to put in the instruction. I'm going to get my old keyboard out, and I'll go to then under math 1 you'll see log 10 blank. So I've got log 10, and I'm going to put list 2. And then under list 4, I'm going to put 1 divided by brackets list 2, like so. And then in the third one, I'm going to do log 10, and because it's the x values, I'm going to write list 1. And then for this one, I'm going to do 1 over list 1. So hopefully your values should look something like that. I suggest pausing the video so you can see, so you can go and have a go at it yourself. Great. So what we're going to do now is we're going to go and do all of the associations. So hopefully yours looks something like this. So I've just written them all down here earlier. So we're going to test to see the linearities for each of these particular equations here. So because it's very easy to forget. This was list 1, that's list 2, this was list 3, list 4, list 5, list 6. So 1 over x was list 6, log x was list 5, 1 over y was list 4, log y was list 3. I find this is useful to write down to make sure that we get the right lists in. So x is list 1, x is list 1, y is list 2, and y is list 2. Okay, so what I'm going to do is I'm now going to go and put each of these, just going to shrink the dink the window there, and we're going to compare the R values for each of these. So I'm going to go to set graph, list 1, list 3, set, calc, regression, linear edge, list 1, list 3, bang, and we're getting, we've got, oh, it's not a bad R value, so it's, R value is negative 0.989. Have I got space? I'm just going to zoom in there, 9, because I just realized my 8's looking a bit scruffy there. 989. And so this, the equation of this line would be log y is equal to 1 point, we may as well keep this to 3 decimal places, 1.923 minus 0.014 x. That's what it would look like. And let's see what it looks like. Oh yeah, it's still very much a non-linear curve at this point, so it hasn't done that much to change it. So if we bring up the residuals, it will still be very much a non-linear curve. So it's okay, but not great. It has improved the R value, the correlation, a little bit better than the original, but from a shape-wise, not that great. The next one I'm going to look at is the X and the reciprocal Y. So remember, if you can't, not understanding what I'm saying, that's reciprocal is the 1 over Y. That's what I'm saying there. So we're going to do that. We'll close this, set graph setting. I need to do list 1, list 4. Thank God. I'm so glad I wrote that down, primarily because it means I don't have to think. List 1, list 4. Okay, ooh, we're getting an even better R value here. We've got 0. Because remember, even though those are negative, if it's closer to a 1, then it's, or negative 1, if it's whichever one it's closest to, that's still a better correlation. So 0.996. And so 1 over y is equal to 0.012 plus, now it says here 4.7401 times 10 to the negative 4, so that's 0, we can actually write it like this, plus 4.740 times 10 to the negative 4, that's what that E means, times 10, so that there is E to the negative 4, and this time is just X. We'll put a little X there. And we can see what that looks like. Oh, that's getting, though the dots are very close to the line. It's still a little bit of a curve, but the dots are getting closer to the line, so that's why it's very, very good. Now we can try a log X. So what we're going to do is set graph, setting. X list is list 5, this is list 2. Regression, linear edge, list 5, list 2. And no, it hasn't done anything better than the last one. So the R here, I should actually write R there, yeah, R here, is negative 0.985. And so this one here, the equation would be y equals 88.138 minus 27.655, and I'd write times log X. So out of our correlation so far, the worst one is still the original, so that's okay. The worst one's still the original. This one is better than that one and better than the log X, so logarithm Y is better than log X. The reciprocal Y is currently the winner, so even though it's gone positive, it is closer to a 1. So remember, we're aiming for whichever one is either closest to negative 1 or closest to positive 1. Very rarely would you have a circumstance where they're equally close, and that would be a weird set of data to have, but that's what you're aiming for when we're trying to see which one is the best. Let's just have a look at what it looks like. Oh yeah, we've got a big clump over here. Still a little bit of a curve, but it's doing okay. Now let's try the reciprocal x's this time. So we've got a setting, and this was list 6, list 2. So make sure I did that properly, yep. And I go to calc, regression, linear reg, list 6, list 2. And this is dreadful. So here we go. So we've got 0.84. So what's it, 0.846? If I was writing the equation to this one, I'd write y equals 58.544 plus 32.799, and in this case I would write times 1 over x. But I can also, you might remember from a previous video, I can also just write that as over x, like that. So, out of all of our values here, the best one, the best of these is still this friend here. It's got the strongest one, it's the strongest R for this, so list 1, list 4. If we can test to see what the residuals look, oh good lord, just looking at the the final one there, that reciprocal x, that's just revolting. We'll have none of that. So what we're going to do is we're going to just triple check. What we'll do here is I'm going to test what the residual plot looks like for list 1, list 4. So how do I do that? I'm going to go to regression, linear reg. So I'm going to do a linear reg, list 1, list 4. I'm going to copy the residual into list 7. So okay. Yep. And then what we're going to do is we're going to get that. So there's the residuals there in list 7. So what I'm going to do is we're going to have a look at the scatter plot of that. So the x values are list 1. And we're going to use list 7. And as you can see there, it's a sort of pattern, but not really a sort of pattern. It goes up and down. Now, in fact, it looks like, for those who do maths methods, it looks almost like a quartic, but it's much more scattered. So whereas the previous scatter plot was like a beautiful sort of parabola looking shape, this one has dented it a bit. So even though you could argue there's a little bit of a pattern, I'd say that there is no pattern now, because it goes up and down, up and down. And the equation is, and we better write this in words, so it's 1, and it was temperature we wanted. So we'd write 1 over temperature, because it's the reciprocal y, is equal to 0.012. I think it's 0.012, plus, unless I've misread it, plus 4.74 times 10 to the negative 4 x, like so.